Hello, people. Welcome back.
Hello, sir.
All right. So we are gonna try and make it through a few presentations today. Let's see how much we make it through. Um, all right. So bring up this thing here. Okay, so BIM. Here we go. All right. So which one we're going to go through next? Today we are looking on phasing, constraints, and view range. Am I right?
Yes, sir.
Right. So we have a little less time today because we're doing it in this afternoon session, which is 2 hours. It is 6 to 8. Listen. Yeah, man. All right. So who wants to go first?
We'll go first, sir. The constraints group.
All right. Let me stop the share. All right. So remember the drill. We're just gonna go through what the definition, the use case, and then the demonstration part where you show how this applies to the project.
All right, sir. We're ready.
All right. All right. So go ahead and well, let me bring up your thing with your group members first. 1 second. Um, infographics. No, we're looking at BIM. Yep, I see you coming up. And
Hi, sir. This is
um,
Haley Gentles speaking.
right. And this is topic number
This is topic
let me look at
number
this thing.
2, group 2.
Is topic number 2? I thought I had 2 already. Hold on a second. Yeah, what are constraints? 2. Yep, you are correct, Mundo.
One moment.
Ansel, what group were you in? Is Ansel here? Yeah, what group were you in? What topic did you do? Ansel? Ansel and Chambers. Uh, Hold on, I'm trying to check on my end. Um, okay, right. You guys were 3. Okay, I see where I made a error here. All right, because I was wondering if we didn't do 2 already. All right, cool. All right, go ahead. Constraints.
One moment, sir. This one is frozen.
Now let's open the model.
Let's present this. 。 Okay, let's begin. So constraints, building information and modeling. So good evening, everyone. My name is Haley, and my group members are Evelyn Sorto, Leonardo Coombs, and Theron Harrison. All right, so we start with what are constraints in Revit. So based on our understanding and research in Autodesk Revit, constraints are rules applied to the elements to control their size, position, and relationships. So what exactly are constraints in Revit, you may ask? So these now, they ensure that the model responds predictably when changes are made. For example, if I say that I want a wall to be 15 feet long. Once I make a constraint, it won't pass that constraint. So constraint basically help elements remain aligned. It maintains fixed dimensions. They allow components to stay equally spaced or follow geometric relationships such as the parallelism or the perpendicularity. So basically, it just ensures that the model responses predictably when the changes are made. So if we adjust one part of the design, the rest of the model reacts in a controlled and expected way instead of shifting randomly.
Mhm.
So constraints can attach elements to a specific level to maintain consistent vertical positioning. Using constraints supports a parametric and flexible model. When adjustments are made, related components update automatically. This improves the overall accuracy and efficiency during the designing process. Is everybody following so far?
Yeah, well, I am.
Okay, great.
You said a nice
Great.
word there. I don't remember what it was. It was a nice long word. Um,
Perpendicularity.
yeah, that one. All right.
So basically, when I said that this improves the overall accuracy and efficiency during the design process. Overall, this saves time, it reduces the mistakes, making the whole design process more efficient and precise. So basically makes our life easier. So here we have where we broke it down into how it works. We have the rules and logic, we have the alignment and dimension, we have the predictive response, and we have the geometric response. Basically a summary of what we stated before. So when we establish the rules and logic, it basically is a process, or the process begins with the user defining rules and logic. Before any movement happens, you must decide how the element should behave. So that's the first thing that you think about before moving forward. Then we have the alignment and dimensions. So once the rules are set, you establish the alignment and dimension. This is where you physically lock elements to one another or to a specific measurements. We basically use the alignment tool and clicking oh my God, the padlock icon or clicking on a permanent dimension string. Yeah. So moving on to the predictive response, as the word said, predictive, you kind of know what to expect once these rules are made in place. Then we go to the geometric relationship. So after the elements are linked, you define how they interact as a group through the geometric relationship. So industry example. So basically, constraints are commonly used in architecture and construction to mean the design consistency during the revisions. You'll find that a lot. For example, we have images where if this is not followed, you kind of see where, if you see where the arrow is right here, if you can see my cursor,
Mm-hmm.
you can see this is a real life mistake. So basically, the contractor probably follow the plan and say, okay, the window was closer than before. And then you realize that when this is done and you step back, you realize the problem. So basically, these constraints help the architect to not make, or the draftsman to not make these mistakes. So for instance, in residential or apartment building designs, windows can be constrained to stay evenly spaced and aligned along a facade, as shown in the image. All right, so if the building width changes, the window automatically adjusts while maintaining their alignment and spacing. This minimizes the need for manual corrections and saves time, just to add more on what we were saying previously. So once these constraints are into place, it helps us save time because they automatically just adjust. And yeah, so we have our example on the side again.
Mm-hmm.
Okay, so constraints also help to preserve the original design intent, especially when multiple changes occur during design, development, and coordination stages. So, how constraints benefit the architectural industry? I think we kind of explained. I hope everyone is following and have a basic understanding of what we're trying to say. So now, again, it improves the accuracy and adaptability. Constraints in Autodesk Revit improve accuracy, efficiency, and adaptability in architectural design. And next one is the parametric relationships. They enable parametric modeling, allowing elements to maintain relationships such as alignment, spacing, proportion, even when the modifications are made. Next. So greater efficiency and consistency again. It reduces the manual adjustments, minimizes errors, and ensures consistency across drawings and documentations. It enhances team coordination. So constraints also enhance the team coordination as updates to one part of the model automatically adjusts relatable components, supporting the smoother collaboration through design and construction. So constraints found within the proposed Revit file, this is what we came up with.
Good afternoon, everyone. We're group number 2. Today we're presenting constraints. So for that, we're gonna use the Revit sample model to show what constraints are. So the way we find constraints in Revit is we click this icon when it has a dimension and a label next to it. And that's what will reveal the hidden constraints in our floor plan. So as we can see, I'm showing some hidden constraints in this floor plan, and that's how constraints work. That's how we can find them in our Revit model. So for the first example, I just want to show how the constraints help to maintain alignment and spacing automatically. Even if we do try to move a wall, the windows will stay because there's a constraint keeping it together.
Now I will be demonstrating applying my own constraints to the project. So for example, I'll use the align tool to align this window to this column. Click on block to apply the constraint. Then I will select wall and select the move tool. I will move the wall 1 foot roughly. And we can see that the windows along the wall have changed their dimensions. However, this window with the constraint, which we can show when we click the review constraints button, that light blue dash line, the window stays aligned to the column. And when we undo and the other windows move to where they were, this window stays aligned. So for demonstration number 3, I will be
Hello? Did my audio go or did your audio go?
and
Sorry?
you can
Oh,
use the
it come back now. Okay.
you can use the equality dimension equality command over here to equalize the distance between the center of these windows, which I will demonstrate now. So as you can see, it's adjusted. Dimensional constraints, which are the individual dimensional constraints, control exact measurements, while equality, which is the EQ button here, the equality constraints maintain consistent spacing between elements.
Okay.
Okay, that's it, guys. Thank
All
you.
right. All right, good stuff. Yeah, you did define it. You did kind of repeat it a couple times. So, yep. Anybody who did get it must get it by now because you did reiterate it again. Um, yeah, so con you did kind of show where that part was so quick. You were that part where you were showing where it was used in the model. Where was that again? Where in the model was it? You were saying no, you're going to show where constraint was used in the model.
In
And
the menu. Where you can find it? Where you can find it in Revit?
yeah, at that part it was kind of quick.
Oh,
Not when you explain how to do constraints, but
Mhm.
you were showing me where in the project had used it. Um,
oh.
where was you can go back to that part?
Sure, sir. One second.
What part? The
Or
video.
if you remember where it was. By the way, thanks for doing the pre-recording. I think it got a little bit smoother because you already have it pre-recorded. Because you
Great.
realize the model is a bit heavy. By the way, does you're using Canva? Does Canva allow you to upload
Good afternoon.
video files?
Yes, sir, it does.
Nice. How large does the free
Good
tier
afternoon.
give you?
Uh, we're
What?
What's
not sure.
okay,
Color?
well.
Yeah, I don't know how large the video file is.
What
And
is
what
it
did you
called?
use to do the video recording?
CapCut.
Oh, CapCut. Okay, yeah,
Yeah.
cool.
So it was like compressed eventually.
Hmm. Right.
Good afternoon, everyone. We're group number two. Today we're presenting constraints. So for that, we're gonna use the Revit sample model to show what constraints are. So the way we find constraints on Revit is we click this icon when it has a dimension and a light bulb next to it. And that's what will reveal the hidden constraints in our floor plan. So as we can see, I'm showing some hidden constraints in this floor plan, and that's how constraints work. That's how we
Oh,
can.
So you basically turn on the light bulb
Like
to
example,
show
I just want to show
Yeah.
how.
Yes, sir.
where in the project it was used. Okay, all right. All right. Where do you think? Because yeah, you kind of show us where the constraints are. Um, which there's a couple of areas, but and you did kind of mention in your explanation how. Okay, so in this project, where would be a critical point? Should I say it this way? Yeah. Where would be a critical point or critical area where constraints would have been used in this particular project?
Level, sir, maybe?
I mean, yeah, yeah, I mean, by default, levels are constraints because, when you lock it, when you choose, make this wall go up to whatever height, it's automatically constrained. So that is a default. But in this particular scenario, right, where do you kind of mention it, but you see, you mention it in a broad way. So I am trying to see if you have fun, because I remember I say every topic that you guys go through, it's actually been used in the project in a particular way, right? And if you guys manage to find that, then that's bonus points for you. So yeah, you switch on constraints and show say, oh, constraints is here. You can kind of see where they are used, but I would need
Sir,
it to
so like,
go
are you
ahead.
talking like finding the constraints like for the elements like the walls, the
Not
reference planes?
um not necessary. It's almost like I want you to tell me um like in a particular use case scenario in this project where constraints was critically used. Not the default way, like, oh yeah, there are some there. I mean, you can see that, oh, these three windows are equally spaced with a constraint. Fine, that's good. But I wouldn't describe that as really critical. Because this project, I'll give you some hints. Because this project this project was it is a bit large, and there are multiple persons that, you have the structural, you have the ME. When you look in the link section, you can see that different groups of persons were working in this project at the same time, right? So try not to give it away here. There are some critical points, areas that constraints is so critical, even more critical than just making sure the windows are, equal and blah, 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 blah. So what is that critical area that constraints are used in?
You mentioned a lot of people working in the same model, so I was
Right.
thinking maybe if someone else is working in that project and someone else worked previously, they cannot touch whatever they did, or like they cannot change anything. Is that a constraint where Revit helps prevents anybody else from changing it? Or I don't know, something like that.
Well, no, that wouldn't be a constraint. That not fully a constraint necessarily. So no, not necessarily that one.
No. 1 second.
Let's think about it.
We don't have much time, but come on. I mean, guys, you did well. You did your presentation. I think your theory was good, which is great, and you did demonstrate how to use constraints. And let me tell you something, everyone. A lot of people forget about constraints in Revit. I don't know how I can make this even, because you did show an example of how to use it, but when you are, I'm trying to think, if you remember when we did the tutorial this morning and the walls needed to go up under the slab, right? There is an option there for you to link the walls going up to the slab. And really what it's doing, it's constraining the walls to the slab. So by default, like, you can save yourself a lot of trouble by constraining things together. And a lot of times when we're in Revit clicking around, I'm glad you bring up the little lock icon. Am I sharing? No, you are sharing. Okay, hold on, let me share. Let me replace current share with my share. Here we go. I'll just use it with a new project. Right. So I put both of my windows on one side. But yeah, if we draw a wall, come on, if we draw a wall like this, I mean, anything, like even if you draw another wall, come on, going, or no, let me draw a floor. Floor here. The fact that this floor touches this wall, you see that little lock icon there, guys? Like, sometimes it's so easy to ignore this. But, when you ignore it and we just say, okay, we want the floor to be there, and we just say, okay. And then, maybe we're moving stuff around and yeah, go ahead.
Is it a case that when we're collaborating and when we're working in teams, is it that Based on the constraint that are used for that settings, it basically, if one user locks something, the other person cannot change it without like consulting or like referring back to the person for like a request. So therefore,
I mean,
that will help the coordination and
yes, that is important. But what I really looking for is what element is like what element is really important that cuts across every field, so engineering, plumbing, architectural, that it's so important to use constraints with. That is the highlight that I wanted you to mention. So it's like you mentioned windows, fine. They mentioned walls, you can constrain to the slab, fine.
grids.
I'm debating if I should give it because I gave you so much clues. But yes, the grid. Because if you think about it,
I said it in the last part.
when? As in the no,
A while
well,
ago.
I know. That's what I'm saying. So I know you said it a while ago. So the answer is grids, right? So I'm saying that that is one of the most important elements in this project, because what happens is that your columns go according to the grid. Like even if you think about the project that we are creating now, the schematic design drawings that I gave you, they have no measurement. Where are all the measurements?
The grids.
It's on the grids, exactly.
Right.
So that means that the grids are like your ultimate reference point. So that should be, so for example, if you let something constrain to a grid, and because the grid is so important, if let's say somebody who is in structural say, no, this grid line can't be here. It has to go over more because of whatever reasons. When that grid line moves, I'm hoping that there are things that are constrained to that grid so that they move as well. And usually things that are constrained to the grids are like columns and beams, which literally makes your building stand up. So that is one of the most important constraints that was in this project. It's literally what lines up all the columns and beams, and the fact that constraints was used between them. So yes, constraints can be used in anything. If I'm just simply drawing a floor slab, once it touches another piece here, I can lock it, and then that's a constraint. So now anywhere the wall moves, the slab will move as well, you know? And if you try to pull it away, this is the difference with constraints. It gives you a message to say, hey, you're going to have to remove the constraints.
Right.
All right. So there is one small area that constraints are used in Revit, and I did not hear any mention of it. I call it small. It's really important. It's important. But I already give you the bonus mark for finding where in the project constraints was used critically, even though I did give you like hint, right? So you did get that. So, but generally, in general, you mentioned how constraints are used in Revit, and you point out some areas. There is one thing in Revit that literally is built upon constraints.
What is that considered?
This one I'm throwing this one out to everybody in the class. I'm looking, let me see if I can give a hint. I'm looking for an answer from Addison or Thompson. What's that, Javin? What's your answer? Nope. It can be used with the scope box, fine. That I would throw that into this category, but nope. I'm looking for an answer from Davina, Matteo, Addison. None of those people not here. I don't see. Yeah, I've not seen no. Addison, of course, Addison is here. Addison, what's the answer? One super important thing in Revit, of which constraints is the backbone.
So I have a backbone for
Yes.
constraints.
Yeah. For this one, I shouldn't give marks. I should take marks away.
No.
Yeah, I should take marks away from your group.
Oops, sir. I thought you were throwing this one out to the class.
Yeah, but you should answer first. Your group should answer first.
Evelyn
What?
answered parameters. Evelyn said parameters.
Parameters? No. No, it's related to it, but no. Come on.
Related to it.
Come on. Come on, guys.
Yeah. It's related to
Hint. I call Addison. I call Davina. I call Matteo. What do these people have in common? What topic did these people research? You looking at the mirror board?
Sir, levels.
No.
Level?
No. Addison, what topic did you research?
reference plane.
What topic did you research, Addison? You already presented. Oh, trick, it passed and gone already. You put it out of your brain. All right, fine. So the answer is families.
Families.
Yes, families.
Families.
Constraints are the backbone of Revit families. Why do I say that? Okay, look, I have Revit open now, and I'm just picking something average like a window, and I put in a window here, right? Let me go in 3D. So here is this window here in this wall, right? If I want to adjust the width of this window, I go into I can go into edit type. Come on. And I can change the parameter. See, it's related. I can change a parameter called width, which is 3 feet. I can change that to 5 feet, for example. And if I say OK, the window changes to 5 feet. How did that happen? That happens because if I go into edit family, all right. So are you seeing everybody is seeing the screen?
Oh my God. Yes. And it's like the presentations are short.
Oh, you all feeling bad that you didn't guess families? So you actually presented on families? Anyway, are you guys seeing my screen? Guys? Hello?
Yes, sir.
Right. All right. Now, what I'm trying to do, I'm trying to show how everything is interconnected. So yes, when you guys presented on families, you didn't necessarily go into constraints, but fine. Families are only about constraints. The reason why you could change, this one is maybe a little bit complicated. I don't know if you can see it, but for example, width. The width of this window here, you're seeing width equals 2 feet. This is a formula. This is a constraint. And the reason why you're saying width equals 2 feet is that you can insert any dimension in this. And what will it do? It will push this and this reference line. It will push them away or towards each other, depending on the measurements that you put in. Now, these reference lines are linked to geometry that is within the window family. So the very reason why families operate the way they are, as in when you type in a measurement, it changes, is because there are constraints in the family file that is linked to objects. So for example, you can't do this outside of a family. So for example, like this slab that exists now, if you want to change the width of it, yeah, you can go in and you can edit the actual slab. But if you wanted to create a parameter, meaning when you go in the parameters here and you change like a width or a height or a length or something, you have to create a constraint inside the family. So every family that exists in Revit has constraints. Every window, every door. And I don't have any time to demonstrate this. And this is not something that we will necessarily do in the major project. Families is like a category by itself, meaning there are people whose job it is to create Revit families of objects in real life. If you go, for example, to where do you find this? Let's say I can't think of a local place in Jamaica, but if you go to, all right, let's say the USA, mailbox manufacturer. I don't remember the names of them, so I just have to. I'm gonna have to just. Crap! I don't remember the name. Is it this one? Okay, maybe. All right. Okay. Mailboxes in the US, they are standardized. They have to be a certain width because packages have to go in them and everything. So when you are creating your building, you have to like say, okay, what type of mailbox am I using? Just like how you say, what model of fridge am I going to fit into my apartment? You have different models and sizes of mailboxes. And you have companies that all they do is model mailboxes all day, because all they do is manufacture mailboxes, and what they do is provide a Revit model. I don't know if this company does it. So these are all the details. And so for example, you might choose to buy this particular mailbox and they have like a Revit file available for you to download, which this one doesn't have it. Hold on, technical documents. They have PDFs. This is like the old school way. So this is what they used to do back in the day. If you want to buy something to put in your design, you would go onto the website, look on the different model numbers, and they would have some kind of document, which these are not opening, some kind of document that tell you the features of the product, like how width, how wide, how tall it is. And then have to go in your drawing and make sure you have the space for it. Nowadays, most modern companies, they have a department that all they build is families. So that when you are doing your drawing, all you have to do is insert the families into your project. And those families have parameters. And those parameters are based on what they actually manufacture in real life. So you configure the family to what you want in your actual project. I will show you another example, but I just wanted to say families are like its own industry, because if I sell furniture and I have a Revit family of all the furniture I sell, then you are more likely to buy from me because you can confirm that my furniture will fit in your design because I have families that you can put in your design, right? So anyway, I don't want to go any deeper, but that is what I wanted to say. Families are built from constraints basically. And that is in the more advanced, more remember I tell you we're doing like basic Revit. When you go into the more advanced section of Revit where you're dealing with parameters, that's when you deal with constraints, and then that's when you deal with creating your own families, right? When you work in an architectural office, and let's say you use a particular type of window, then what you guys should do is you would create a window version that your office uses, and that window version have different sizes set up already because you already set up constraints in the family file with different sizes because that's what your firm uses. All right. So that's it for constraints. Good job, guys. So that was the only thing I would want you guys to have mentioned, but you did find the secret, the hidden feature with my help, but I will still give it to you. All right.
Thank you so much, sir.
All right.
Kind sir.
So... All right. Next group. Oh, scope boxes said I would go next.
Yeah.
Yes, sir.
All right. Give me 1 second. So just ready up yourselves. Let me stop my share. Stop share. What time is it? It's minutes to 7. Yeah, what's that?
Who's after scope boxes?
That would be can we fit one more after scope boxes? Let's see if we can fit one more.
Yes, sir. Yes, sir.
All right, let's try. Was it phase? No, it wasn't phases. It was
No,
view
sir.
range.
View range.
View range. Right.
We're getting through all.
All right, cool. We can try. Cool. All right.
Model and detail lines also haven't gone yet.
Right. So we'll see if we can get to model and detail lines. But we have the lecture sessions, which is particularly for dealing with the theory. So don't worry about it. As long as we can get through. All right. So we just saw constraint. Evelyn constraints. I have Evelyn names twice. This thing. Okay. Oh, I didn't realize you came up on the screen. All right, cool. Ready when you're ready.
Good morning, good afternoon, everyone. Good night, everyone. My apologies.
All right.
We will be presenting on what are scope boxes. Scope boxes are very interesting. We use them often, especially in the current project that we're doing. We use them in the start. I'm going to show you guys that as well, in case you don't remember. But my partner Daniel here, she will go into explaining what exactly is a scope box, the industry usage, and then I will be doing a live demonstration. So I hope you guys enjoy.
Okay, what exactly is a scope box? So scope boxes are 3D non-printing annotation features used in BIM, Building Information Modeling software, particularly Revit, to control how different parts of a model are shown and coordinated across multiple views. They facilitate the organization of large or intricate models, ensuring consistency and simplifying the management of drawings. So scope boxes are created in plan or reflected ceiling plan views. It can be drawn as a rectangle in plan with an adjustable height, and it is named and assigned in view properties. So functionality. It locks cropped regions once assigned to a view. It can be applied to multiple views simultaneously. Editing the scope box updates all assigned views, and rotating a scope box rotates the cropped angle. So a few limitations for scope boxes is that they're only rectangular shapes. They're only rectangular in shapes. It cannot be angled. It can be hard to manage in large projects at times. So if you create many scope boxes in a large model, it can become difficult to keep track of all of them. And at times there are alignment and precision issues. So sometimes scope boxes don't always snap to other model geometries like walls or grids, and users can't input exact sizes or constraints numerically. So industry use. Scope boxes in architectural firms enhance efficiency in documentation and collaboration, particularly for repetitive or large-scale projects. BIM coordinators utilize them to divide linked models by zone and system, facilitating accurate clash analysis, resulting in cleaner models and reduced construction errors. Scope boxes also enhance workflows by simultaneously cropping multiple views, ideal for renovations and layouts, thus saving time on repetitive tasks. They maintain consistent grids and levels across large projects, improving annotation clarity by managing 2D or 3D line visibility. Additionally, for phase construction, they facilitate element visibility toggling, reducing model clutter. So now I'm gonna play a video kind of showing how scope boxes can be used. Yeah, can
be used in the industry.
Can be used in the industry.
Remember, you have to share your audio.
Oh.
Right. So click back the green button and check share audio as well.
Share sound. See this.
Hi all, and welcome to this week's Navigate Feature of the Week video. In this video, I'll be going through and demonstrating how to utilize the Scope Box Sync feature. And I really like this feature because it allows teams, as teams are on collaborative projects, linking in each other's models between architects, MEP consultants, and structural engineers. There's a lot of moving parts, and so one thing about the scope box is that I think it's a very underutilized and underrated feature because you can associate levels to it, grids to it, and also use it to clip your views. I know a lot of architects tend to use scope boxes, but as a consultant, you would have to replicate those scope boxes yourself if you really wanted to utilize those same scope boxes. But this feature allows you to just with the clicks of a few buttons import scope boxes from a linked model and import it into your own working model. So in this example, I'm working as a MEP engineer, and I have my architect's model linked in, which is grayed out in the back. And these green lines indicate, or these green boxes indicate scope boxes. Now, let's say, for example, I got a architectural file from my architects and I want to import their scope boxes into my working environment. So I would go over to Navigate Accelerate, over here in the collaboration, click on Scope Box Sync. And then you'll get this Scope Box Synchronizer dialog box. And in this box, what it's showing you is that from my architectural model, I have 5 different scope boxes. So the first scope box you see here in green is the overall plan. It's checked off. What that indicates is that I have already synced, or I have already transferred that scope box into my working environment, and I need to do, and I don't need to do anything with that scope box. Now, if you notice wing A and wing B, they are highlighted in orange and have an exclamation mark. What that indicates is that these 2 scope boxes were already linked into my working environment, but they have since changed in the architectural model. And so it's asking me if I want to update those 2 scope boxes to mirror what my architect has. And then Tower A and Tower B are highlighted in blue, and they have this minus status, meaning that it's missing or it's not in the project. So these are new scope boxes that are being introduced from my architect's file. Now, to update all of this, it's with the simple click of a few buttons. I can go ahead and say import missing scope boxes from link, and that'll import my Tower A and Tower B. I can say synchronize project scope boxes with link, and that'll synchronize these 2. I can also I can also filter through the scope boxes. Let's say I just wanted to work with a certain set of scope boxes, so I can go ahead and say tower, and it'll only list the ones that have tower in it, right? And so if I go ahead and say import missing scope boxes, it'll now place Tower A and Tower B scope boxes into my project, and then I can say synchronize scope box with links, and that's going to also synchronize the ones that have changed, and I am done. Go ahead and hit close. And that's how I am able to utilize the Scope Box Sync tool. So thank you for watching this week's video, and I hope this was informative.
Okay, so now okay, we'll do a demonstration. Just share. Yeah.
Hello?
Oh, hold on. I need to allow. Hold on.
Yes, sir.
Allow. Yeah.
Requested permission.
All right, go ahead. Mhm.
So, as Daniel would have touched on, you can dive deeper into scope boxes, what they are, and it has a lot of different functions. But essentially, it is really used for organization for the most part. And let's go on the sample project so I can show you. Even on the sample project, as you can see, scope boxes aren't things that you necessarily print when you're doing presentation drawings. It's just to help you with your workflow. So even when you're printing, once you press print, normally there will be an option to hide the scope boxes. A lot of the time, that's always used because it's just, as I said, just to help you with your drawing. So now, how do you actually place a scope box in Revit? Well, one thing for sure, if you go in 3D view, you can't place a scope box there. It can only be done in plan. Because if you go in 3D view, the option is not there. As you can see, it's grayed out. So once you go in the plan, the option would then become available. In this, for example, the sample project, they hid all the scope boxes, so you currently can't see them. And it's underneath a specific template. But if I was supposed to unhide them, see it's loading. You can see they use a lot of different scope boxes, even one for the overall model or one that they're showing a specific detail. It's just to help them with organization. So what you would do would then be to go in view, click on the scope box option, and then that's where you would then create a scope box by clicking 2 points over whatever it is that you want to show. So now, for example, let's say that we want to showcase a staircase using a scope box only. After doing that, first we need to unhide this, make that dependent. It's on a specific template, so you're gonna have to take it off of that template. To do that, you would go on the identity data, and then you click none. Apply. And that would allow us to now unhide all of those scope boxes. So you can now unhide all of them by category. So loading, give it a second. So with the scope box now, we would have created the scope box around the staircase. Now, if we go into 3D view, all right, and then we scroll down to extent, you'll see in the extent option, they have a scope box. You can then select your specific scope box, which we want is scope box 3. And it will then be the view, or what you're seeing would then be limited to what's inside of that specific scope box. And also, you can use the scope box and align it to certain grids or levels. Also did a sample model because that would be easier in showing you that. For example, this, and Daniel did mention a part where you can't necessarily rotate it, but that isn't necessarily so. Well, you can't get a scope box as an angle because it's rectangular, but you can use it for drawing purposes to rotate a drawing so that it's a bit easier for you to work with. And how you would do that, for example, let's say that this, as you can see here, we have an angular part of the building, and you don't really want to draw at an angle. So for drawing sake, same way how you would create a scope box, you would go into view, then click the scope box option, draw a rectangle. After drawing that rectangle, what you want to do now is rotate the scope box. So you can click on a corner that you know, and then click and rotate the scope box to that angle. And once you have done that, you're then able to see a second. So open this. If you go down to extent, you can click that scope box option, and then it will rotate that specific part of the scope box. So it's easier for you to draw your walls or put in furniture, and it's easier to give you an understanding. And then next, you can also apply scope boxes to grids. So let's say that your grid is all over the place and you want to organize it so that it's easier for your workflow. Give me a second. Let's take off this. Okay. So in the overall drawing, let's say that you want all of the grids here to be aligned to a specific scope box or at a specific placement. You would then create a scope box. View, scope box. Then you highlight the area. what you can do after highlighting that area, would select everything. And when you're aligning the grid to the scope box, the grid, they have to intersect with the scope box or it won't align to that specific scope box. So now after highlighting everything, you would click filter and then you only want the grids to be selected. You click apply. And then right over to your left in properties, you see scope box. You click the down arrow and then you click on this specific scope box, which would be scope box 4. And then once you apply, you will move the grids. As you can see, if I move the scope box, it will also move the grids. So it's a bit easier for, let's say you have a big drawing and you want to move all of your grids at one time instead of you doing it manually and you're moving each individual grid. This is a quick way for you to just move all of them at once. And also you can use scope boxes for your floor plans. Now we go in a 3D view for your levels. Sorry, you can use it to align your levels as well. Scope box. You'd want to highlight the levels and then you can attach it to that said scope box. And now if you move the scope box, the levels will also move. And that's about it for scope boxes. So one, it helps you to align your grids, your levels, and it also helps with rotating your views, especially if you're doing a drawing for, let's say, an angular building. It will be easier for you to work at right angles. And it makes your drawing more cleaner and organized. That's essentially it for scope boxes.
All right,
Thank you,
cool.
everyone.
Cool. All right, that was it. All right. So, well, before I go any further, where in the model was scope boxes used in the sample model? Yeah, they were used in many places. Did you mention? I'm trying to think back to say if you had mentioned it. I think you demo. Oh no, you did show, right? You did show where they were. Okay, no, well, so what were they used for in the model? What were they used for?
So from my understanding, they would have been used to help in creating certain views, or let's say that detail, they want a specific detail, so they would zone out, for example, here, this area. Let me see. No. Did I unhide them? Oh, wait. I didn't unhide them. It's loading. Give it a sec. So let's say even for the grids overall, I realized that some of the grids would have been attached to scope boxes, like I would have explained. So it's easier for them to control the placement, so they wouldn't have been aligning everything manually. Or let's say, let's zoom in. Even for here, you can realize that they have a scope box in this specific area. So they
Exactly.
probably use the scope box to zoom into that specific area and do drawings or certain details, for example, for that specific area.
Right. Sure. Okay. I'll give it. I mean, the scope box one was probably one of the easier ones to find. because it wasn't like hidden. Like there wasn't some really interesting way of using scope boxes that would have made it difficult to find. So luckily for you guys, you did find where it was used in the model, right? Some persons had it harder, like the people who did curtain wall had missed when they used the curtain wall for the solar panels. So, the world no level. So yeah, but scope boxes is much more simple. Um, I would argue that probably one of the where was it? You have the model open. All right, so look in your views under uh where do you have it there? Look in your views under yeah, under no, not that one. Yeah, there's so much views in this that I should not have closed it. Hold on, let me tell you what name. Well, it's not going to tell me the name of the view. All right, there is one there that shows you the stair tower. And they have a view that zooms in specifically on the stair tower. And it's because there were some scope boxes that were used to highlight that. Um, I don't remember the name of the view because I already closed it. I don't know if you could find it so that you could show it. It was one of the 3D. Okay, hold on. Right. Oh, you did find it. Good. Right. So for example, I mean, you could have isolated this view by doing it the manual way, but they just drew a scope box around it just to highlight this particular area. So yeah, that's pretty interesting. All right, scope boxes. So yeah, you did find where they use the scope boxes. And yeah, the basic use of it is to help organize the drawings. I would say I'm really pleased that you also highlighted the fact that we use scope boxes a lot when we were setting up the major project. All right, so you are going to be using scope boxes a lot here. And it really does help to in your demonstration where you show how you link your grids to the scope box, it really does help to keep everything in line for you. All right, scope box crew, good work. Let's take one more, and then that will be it for today. And then we continue. So I believe we said Nixon, what group were you?
So links, models.
Links and models. You had said you wanted to go to them, and so from when I asked?
Yeah. So,
All right. And I know
so,
that, yeah, go ahead. What are you saying?
so view range going on?
Right. So let me see. I have written down. Oh, I deleted. Yeah, I totally, oh man, I totally deleted it. When I had picked out those three groups earlier today, when we had spoke. All right, tell you what. View range. Let us do links next week because there are some things that I want to highlight with links, and the time is too short to do that one because that one we are going to be using links in our major project, so I want to give myself some time to explain that. So let's do view range now, and then we'll do links next week. All right, Nixon?
Okay, sir.
All right.
Sir, are we doing model line and detail line today or?
No, we're gonna push that to next week because we just have 40 minutes remaining. Right. But it's fine, guys, because we budget the lecture time to go through the presentations. And when we finish the presentations, basically we're going to use the lecture time to work on the major project. So the lecture time is bonus time, kind of. Right? All right, so let's do view range. Okay, so, and I just saw scope boxes. Scope boxes was which scope boxes was which topic again? Scope boxes was number 4. There we go. Yeah. All right, that done.
Should we start, sir?
One sec. Oh yeah, it's here. All right, yes, go ahead. So we're doing scope boxes.
Good evening, everyone. My name is Anthony Collins. My group members are Shania Proctor, Joshua Watson, and Mikesha Lawrence. So we'll be looking at view range. What is a view range? So a view range, specifically in Revit, otherwise known as visible range, is a set of horizontal or invisible planes consisting of a top cut plane and bottom. The top and the bottom clip plane defines the upper and the lower limits of visibility, while the cut plane determines the height at which elements are cut. These three planes define the primary range. So in addition to the primary range, we have the view depth. It is strictly about looking at what's below the primary range or the bottom clip plane specifically. So these elements are what's below the floor level.
the four main planes. You have the top plane. This is how high the view can see. The cut plane. This is where the plan is sliced, typically around 1.2 to 1.5 meters above floor. The bottom plane. This is how low the view can see. The view depth, however, is extra depth beyond the bottom for basements, foundations, and lower levels.
Oh, you sharing? Is that video?
Yes, sir.
Now we'll be looking at
Hey guys, I want to show you this little but very important feature from environment for Revit plugin that can save you lots of time in landscape architecture projects. This feature is global view range. So the principle of this feature is to quickly change the view range for either views or view templates across the entire project with a few clicks. Let's say you start a new landscape project and receive the architecture model through link. As we want the model to relate entirely to the sea level, we'd have to change each view or view template every time we start a new project. This can be a tiresome and time-consuming task. With this tool, I can easily choose which view or view templates we want to change and the desired view range, and voila, our model is visible in all of the selected views. For architecture applications, it can be useful if the field height has changed and you want to update view range in different floor plans. Let me know if you found other ways to do it.
Now we go into view range in terms of using it in the software. So while the demo video is being played, we'd like you guys to look out for certain things. So first, applicability. This only works in plan views and reflected in ceiling plans. You would not be able to see it in any 3D views or sections and elevations. Also, its location in Revit would be found in the Properties palette, where you then click Extents, then you go to View Range, and then you can edit such view range. Alternative access is through View Properties, inside View Template settings, and View Template controls view range across multiple level views. You can create one by these following steps: View tab, then to the user interface, then keyboard shortcuts. Then you can search view range and assign a shortcut and save. Yeah. Example VR. Now we would have a conclusion and then move into the demo.
The view range controls the vertical depth of a plan view. It defines how high the view sees, where it cuts the building, and how low it sees. By adjusting the top, cut plane, bottom, and view depth, we control what elements appear in a drawing without changing the model, as you can see in each examples below.
We now move into the demo.
Can everyone hear me?
Yeah, I can hear you.
Okay. So regarding view ranges, it basically allows you to see or allows you to choose what you want to see in that specific view. So in order to get to view ranges, you go into the Properties tab, scroll down, and you would be able to find view range right here. The shortcut for view range would be pressing VR, where you would see the window pop up. Here it is. So as you can see, what was shared before, you'd see the top plane, the cut plane, the bottom plane, and the level plane. What allows you to
see what is on the plan view right here is the cut plane. The view range only works on the plan view. The view range only works on the plan view. So in order to manipulate the view range, for example, you want to show the impact. You would, for openings, for example, if you raise the cut plane to match the top plane, like so, door openings would become no longer visible. If you lower the cut plane below its default, you're able to cut through the furniture or cut below the furniture to the point where you're not able to see anything. What view ranges also do, they allow you to read the plans a lot more easily. So they exclude the unwanted areas or noise. So what is on the plans are easily readable. So if I raise the top plane to level 4, for example, and press apply, you realize that certain furnitures that would be on the upper level or the selected level would now appear. This basically illustrates that view ranges are essential in the documentation process, which allows the construction team to accurately read the measurements and such. Another very important section of the view range menu is the depth. So what you're seeing right now is level 2, which is right here. If I drop the view depth to the parking level, you'll be able to see some features of the parking in plan view, which is right here. This concludes my presentation on view ranges.
All right. All right. So that's it for view range.
Yes, sir.
Okay. All right. Um, so as usual, I'm going to ask a question. What critical, we know what view range is. It allows you to, you're basically slicing the plan in half, and the view range allows you to dictate how far down do you see. So you did explain that if you cut the cut plane higher above, your doors, then you're not going to see your doors. What area of this drawing was view range critical? This one is going to be challenging for you. You know why? Um, but let me still throw the question out. Let me still throw the question out. So the question is, as usually I ask, where in this drawing was this feature used critically? As in, without it, it just wouldn't be possible to communicate the drawing.
Or is it in the floor plans?
I mean, yeah, but is it more specific? Like, obviously, like, because, okay, yeah. So everything has to have a view range. It has to have a cut. All right, this is why I say it's going to be difficult. All right, so let me start from the beginning. First disclaimer. I just remembered that I was supposed to say this for the previous group. That did, what was before this again? Scope box, right. The video that you showed is actually a plugin for Revit. It's not native to Revit, meaning when you open Revit and you want to do that thing where you import scope boxes, by default, Revit doesn't do it. So that is an add-on feature, which is a plugin. Now I bring up that because thank you, view range people, because you also use a video, but that video is also a plugin. Now, plugins are fine, but the challenge with using a plugin is that it has to be supported by the author, meaning that I could develop a plugin today that creates a magic button that when you press it, it generates all the elevations for you. But let's say Revit 2027 comes out and I decided to retire and I say, I don't want to make plugins anymore. That would mean that you wouldn't have that plugin anymore to use because I would have to update my plugin to version 2027. You understand what I mean?
Yes,
So,
sir.
right. So this is why plugins are a little bit risky to have a part of your workflow because if you depend on it critically, and usually plugins are made like from, independent developers, you know what I mean? Like a lot, by the way, there are firms that create their own plugins. So if you're a firm that work particularly on bathtubs and that's all you do in Revit, you just work on bathrooms, for example, and you create some plugins specifically for you, then fine. So the reason I bring that up is whenever you're doing demonstrations, I would not include plugins as a viable way to achieve what you're achieving because it's only good for right now. Plugins come and go every day. So you would want to try and use the features that are built in into Revit because you know that when the next Revit come out, that feature will be there. And the next one, that feature will be there. But there's no guarantee that the plugin will be there. You get what I'm saying, guys? So this is just a general note for anybody going forward and even for your everyday use, right? I use plugins in Revit as well, which is great. But I'm just saying as a disclaimer that you have to be careful if your whole life depends on a plugin. Well, the person who made that plugin, if they decide, I don't want to make this plugin anymore, then your life is now upside down. You know what I mean? So that's my first disclaimer. All right, so view range, you guys have perhaps one of the most confusing things to explain because view range can be very confusing. And I don't know if this has ever happened to any of you when you're in Revit and you're drawing something and for some reason you're not seeing it and you're just like, is it hidden? Is the view range need to adjust? And then you open up view range and then you see all of these different lines. So I'm glad that you guys attempted to like go in and explain what these lines are, which is good. But because your topic is so confusing, um, like it's almost impossible to explain view range without showing an example. Now, in your demonstration, I'm glad that you guys showed that example of, look, if you carry a cut plane above your door, you're no longer going to see a door. So yeah, that was great to show. Um, so I'm hoping that everybody here kind of leaves here um understanding how view range works. Now, view range group, I don't think you're going to find the secret. Not secret, but I don't think you're going to find that special hidden place that view range was used in this project. And the reason for that is that there is a topic that you guys didn't mention that has to do with view range? Do you know what that is before I say it? No? I'm just testing the waters first. Do you think you know what it is? View range crew?
Sir, we're still here.
Do you think you know that what topic you did not mention? You
No,
did
sir.
cover the basics. You did cover the basics, which is good. It's kind of like the group. It's kind of like constraints, where constraints group did cover the basics, but they didn't talk about constraints in families, which, that's not really the focus. So that's not too bad, but it would be good to mention it. For view range, however, this one is critical. So I want to just let me share my screen here. This is important for all of us to know. So let me share my screen. Are you guys seeing my screen? Hopefully, yes. Yes. All right. Okay, why is it not going over here? Why? Is it because I have a window open? Yes, I do. All right, yeah. All right, you guys are seeing my screen. So remember my little window that I created here? All right, so let me make my floor a little bit longer. Let me just throw in a piece of furniture here. Do I have any furniture in here? Do I have a couch or something? Let me just throw in a toilet, because it's available there. All right. Now, if I go to a plan view here, I'm seeing my window and I'm seeing my toilet that's here, right? Cool. No, maybe I shouldn't have used a toilet because it's just weird having a toilet there. But anyway, let me draw the rest of my. So this is the rest of my wall. This is my floor slab that is here. Make it a little bit. All right, you know what? Maybe let's not use a toilet because it's just weird. Me, toilet in there. Yeah. All right, so this is my floor that's there. Let me look on this in 3D. Yeah, oops. That is my floor that's here. How tall is this level? This is level 2. I'm going to make this wall go up to level 2, which is like that. All right, good stuff. Good stuff. All right, so what I'm going to do here is I want to have I want to have this go a little higher here. That's here like this. That's a bit like that. To make this a little bit more organized, I'm going to go to my elevation view. Any one of these elevation. Copy this up. Maybe like another level feet. Doesn't matter. And I'm going to make these walls go up to level 3. That's offset. Then I'm going to draw another window here, like that. Maybe like about that. And I am going to put another floor on this other level here. Now, the reason I'm showing you this is little, yeah, let's have a little overhang right there. Yeah, because let's make that interesting. I want to leave this side open just because I want us to see what's happening here. All right, let's throw in a little railing up here. We're going to put the railing on level 2. Okay, why did you have to go over here? Let's strap a railing there. All right, good stuff. All right, so this is where levels really come into play, because if I go to my, I just have 2 levels here, right? Notice that I have level 2. Let me, this is my scope box. I'm going to carry my scope box in. Remember we spoke about scope boxes, so. All right, so this is my level 2. Now, firstly, this is my level 3, which is kind of my roof. So this is like a mezzanine level, and I'm able to see down to this level here. Let me remove this wall so that we can see everything clearly. And I'm going to find a better piece of furniture apart from a toilet. Hopefully, I don't want to have to import anything. Really, Revit? You can't just give me a couch or something? Circuit breaker thing? Sink? Sofa? Really? Okay, fine. I'll just put a toilet. Doesn't matter, guys. You get the idea. I'll just put a toilet here. All right, so we're talking about levels. We're talking about view range. Now, if I go to my, if I want to see what is happening on my upper floor. Okay, firstly, how would you describe this? Is this 1 floor or is this 2 floors? What is the name of this situation? There's an architectural name for it. Who can tell me? What do we call this in architecture?
A mezzanine?
A mezzanine, exactly. Now, mezzanine are going to be the bane, the nightmare when it comes to view range. Because if I go to level 2 here, I'm able to see this that is here, and I can look over and look down to see the toilet here. Now, there are some times when you look down and you're not seeing the toilet that is here. Hold on. So what I'm going to do is I'm going to disable this, right? So this is what you would normally see, right? Now, how can I see the level below? View range, people. Let me bring up my view range.
Could we change the depth?
Where is my view range? Oh, here it is. Here we go. You can increase the
depth, sir.
All right. Yeah, you can increase the depth. But what about, so number 3 here is the primary range bottom. Number 4 is the view depth level. Which one of these would you increase? Because if I want to see the level below, would I want to move my primary range bottom down, or would I want to move my view depth level down?
For the primary range, bottom range.
Why?
Oh.
You know that was coming next, right? By the way, I don't want you guys to feel any way, these presentations are here for us to learn. You guys did cover the main points, so that's good.
Sorry,
but I want to go into these nuanced reasons now. Yeah, so go ahead.
All right, because from the split plane, the bottom primary range is actually looking down. So if I was to increase the depth from the bottom plane, primary range, sorry, depth bottom down, then it would cover more ground.
Yeah, but both of them can cover ground. Because you can adjust the offset.
True.
So both of them can do the same thing. And guess what, guys? Every time you see this option presented to you in Revit where one thing does two things, and you say to yourself, but why would Revit has... There must be a reason why Revit have these two options here, right? So hopefully you guys are following. So if I here, I need my pen. Or you know what? Let me grab a picture. It's easier for me to just drop this in mirror board here. There we go. I'll just drop it right here. Right. So the question was that if we have an object that is down here, well, if we have an object that is below, we have an object here. So this object could be captured in the view depth, but we could also move the primary range down and we would also be able to capture it as well. Now, the main difference between these two is that the difference is the word primary. So primary means that where do you consider the level to be? That should be, by best practices, your primary range. So meaning that your view depth level is below what you call your primary range. So in our example here, right, if I go to a side view, where's my 3D view here? Now, this scenario is pretty open because, do a screenshot. In our mezzanine example here, where would you describe your primary level is? What is your primary level? Is it level 1 or level 2? Your range
Level 1.
is level 1?
So level 1 still.
So level 2.
Level 2? Okay, good. You know what? I'm happy that there are multiple persons here saying different things, because the answer is whatever you want it to be. So if this is a mezzanine level, if you consider this to be a mezzanine, meaning that, you know, I'm here overlooking somebody using the toilet, whatever, and I'm here overlooking, so I consider all of this to be my floor, if I am indeed considering this a mezzanine level, right? So if I consider all of this to be my floor, then this would be my primary range here, my primary level. This is my ground floor. But on the flip side, if this is a 2-story building and I consider this to be a level and this to be a level, if I am on the first floor plan, meaning I'm on the upper floor plan, then this is my primary level and this here is my view depth. If only if I consider that these are two different spaces. There's a space here and there's a space here. You guys see the difference?
Yes, sir.
Exactly. Now, this could work for this scenario anyway. I could consider all of this to be one big space, meaning both upper and lower, or I could consider this to be two independent spaces. whichever one you choose, if these are two independent spaces, then that means this is your primary range, your primary floor level, right? However, if you consider this space to be your main level, your entire space, then that means this is your primary level. I hope you guys are seeing that. So if this is my primary level and I wanted to be here looking down, then what I would want to do is I would want to adjust my primary level to be here. That means my view range is below here, because my view range is always below my primary level, right? I would not put my primary level up here because that would be like cutting above your door. You know, if you're in a floor plan, you wouldn't put your cut plane above your door. Usually that's how you if you consider a space to be a mezzanine level, the entire from floor to ceiling is like the floor, and then you have an in-between level, right? So anyway, the reason that I bring this up because in our little example scenario here, there are two ways in which I can see this toilet below right here. I could I could either let me go back to my level 2. Oops, my level 2. Right, and let me go back to my view range. Right, I could either choose to push my primary level down, or I could choose to extend my view depth. If indeed my primary level is down here, so let's move the primary, if my primary level is down here, then that would mean that the bottom would be level 1. And the view depth would be the level below level 1. And if I choose OK with that, then I'm able to see this below. Now here comes the trick question, guys. Here comes the trick question. How can I see this window below here? Remember, let me show you this in 3D. Remember, we have a window up here, and we have a window down here, and this is and I am considering all of this to be one floor. However, when I go to my floor plan, I want to be able to show the window that's down here. How can I see that window? View range crew, any suggestions?
Sir, adjust the view depth.
The view depth. No, but the view depth is going to, my view depth is already, it's showing me below the toilet. Are you saying adjust my cut plane?
Sir, probably never understand the question I asked properly. So can you just repeat it, please?
All right, what I will do is, let me pull out my 3D view here and dock it here. All right, so this is my plan view here, and this is this in 3D. So this window I'm seeing up here is this window here. Now I want to see this toilet down here, which I'm seeing, which is great, but I also want to see this window, because right now it's not showing me that there's a window in this wall.
Okay, so therefore the top window, that's the one that's being cut, right?
Yeah, that's the one that's being cut now.
Okay, so therefore I think you'd have to turn on underlay. Is that it?
No, granted that would not solve the problem, but underlay is almost like it could almost be like its own topic, but it's kind of too small. You know what? Next year I'm going to say view depth and underlay is together. But anyway, for now, so the answer is not underlay.
Sorry, no, give up. Adjust the top plane.
But what will happen if you adjust the cut plane?
The top one.
They lose the top window.
Yeah. Yeah.
No, but you can duplicate it.
No, you can't duplicate the cut plane. So let me jump to the answer because oh my goodness, it's 8 o'clock already. Jeez. All right.
So we don't want to give up now.
No man, but you're not giving up. You're not giving up. But this is why I was telling you it's going to be difficult to find the secret answer in the sample project. There is a critical part of view range which you didn't mention in your presentation, and it is called plan views.
What?
Yes,
What's that?
plan
What's that?
views.
Say, explain that.
Yep. Sorry, not plan views. Plan region. Plan region. Sorry,
Oh.
region. Right. Plan region. Right? Anybody ever heard this before? Plan region? Some of us might be. Some of us that use Revit. So, plan region is where you can create your own. Hold on. You guys almost got the concept right. Somebody asked, can I duplicate the cut plane? And the answer to that is kinda, by using a plan region. So a plan region is where you can create another viewport, another portal, another, let's call it view portal that has its own cut plane. So what do I mean by that? So in order to do that, you're going to go to view and you're going to go to plan region, which is, oh, I need to be in the plan view in order to do that. And I'm going to go to plan region. Now I'm going to draw a plan region like this, just to kind of demonstrate the point, and choose OK. Now, if you look here, you'll see this dash line that is here. And what this dash line is, if you click on it, it has its own view range within your current view range. It's like you have a view range within a view range. You guys get where I'm going with this? Maybe? Hello?
Kind of, sir.
Kind of. So what happens is that I can click on this view range, which brings up its own view range setting, and I can say I want my cut plane for this view range to be like minus, this looks like about 10 feet or something, minus 10 feet, right? I can also set my, so notice that when I put it, my cut plane to minus 10, it shows me the window below. Now I am purposefully doing this here. Why is it only showing me half the window?
Because of the scope box.
Exactly. It's not a scope box though. It's a plan region. So plan region has its own view range settings. So I can have a plan region just to show me this window right here. Because if you think about it, without plan region, there would be no way for you to know that there's a window here. Because if you move your cut plane from this level to that level, then it's not going to show this window. Are you guys following?
Yes, sir.
Right. So the answer to that is plan regions. So plan regions is a part of view range, of your whole view range topic. Plan region is a part of that. Technically, underlay is a part of it too. But underlay would not solve this issue, right? Now, the same reason, crap, well, I'm out of time. But I just want to say that if you were doing a reflective ceiling plan where you wanted to show the light fixtures on the roof, right? That is where the top comes in. Because some people ask, what is the point of having a primary top range? It's not like, because when you're looking at a floor plan, you don't really care about the top. Like you're always looking down. But when you are doing a reflective ceiling plan, you're looking up. You get me?
Yes, sir.
So this is where, so if I am in this same mezzanine level right here, right? If I'm in this mezzanine level right here, and where's my sketch tool? It's here. Yeah. And I was, it's not sketching. This would be my last point here. It's fine. I will copy it. And I'll just paste
How
it.
about this one though? With the plan region, because I noticed that it's cut. Like
Right.
when you look at it and from the floor plan, it looks like it's cut. Wouldn't that confuse people? Like, yeah,
That's a
they're
good point.
both.
Yeah, that's a good point. So what would you do? You would use constraints to say, all right, I want to constrain this plan region to, let me turn off thickness so you see it. To what?
To the window.
Exactly. So this window will always be visible, no matter what size you put it and where you put it. Let me make it a bit more. Oh, well, because I'm adjusting it. Okay, hold on. Right. And this is like a topic overlap, because the reason why you would constrain it is you might end up moving the window and then you're going to move it out of the plan region and then you no longer see the window. So you would use constraints with the plan region now. So now you can't tell me that like, look at that. That's your window right there. So anyway, we have to wrap up now, but what I will leave you with is how it was used in the project. Come on, project. Here it is. Okay, so it's very hard to see plan regions because they are the same dash lines used for for scope boxes. So yeah, Revit needs to totally work on that. Anyway, I'm using black and white mode. That's why it looks so weird. So yes. Do I have a window up? No, it's CA. Come on. There we go. Right. So this is looking more like what you would normally see. Right. So along this facade here, this was a very tricky facade to do, because when you look in 3D view, I don't know if well, you can't really see it. Hold on, how can I show this? I can show it in elevation. Yeah, let me look at the elevation view here. By the way, you can double click these to see the views. All right, what you notice is happening here. It's sloping. So this is a similar situation where the cut plane of something that is here, you would not see the doors that is down here. Are you guys seeing where I'm getting?
Yes, sir.
Right. So if I chose to cut something to show a door level here, by the time I get to here, it is above these doors here. So they had to do plan regions for the lower section, for the lower floor plan. But when you look on the floor plan, you don't really notice it because they did it in some clever ways. So all of these spaces here are stepping down. Let's use the schematic plans because these plans look a little bit confusing. So if we use the more presentation friendly plans, right? These. So each of these stores, so this is a store here, this is a store here, this is one here, this is one here. All of these are stepping down, down, down. But you are still able to see all of the windows and doors as if they're on the same level, but they're really not. And the reason for that is they're using plan regions, but what they do, they hide it. But if I unhide now, it's going to get crazy because there is so much lines. Like, I'm not even going to... It's somewhere in this gibberish, but it's in there. So anyway, guys, that is plan region for you. So this is what I was saying, guys. Deliberately, you have one of the most confusing topics. You see what I'm saying now? But it is a critical topic to learn because you guys are going to experience these things every day. Worse in Jamaica where things are always on different levels and you need to be, you need to show a window that's lower, or what about a high level window that you have in a bathroom, right? It's going to be very tricky to show that. So plan regions is the way you do it in combination with your range, your view range, in combination with your underlay. I would like to go into underlay, but we're totally out of time and I'm out of a voice. That's it for class today. So thank you for your presentation. As I said, you did cover the main points, but you did miss some as well. And I'm glad that I was able to explain it to you. Hopefully everybody here was able to follow. All right.
That's sir.
All right. So we will continue with our presentations next week. Next week when you come, we'll be moving into landscape terrain, and we're going to tackle that curve step. So I need everybody to do some jumping jacks to be ready for that class, to do that curve step, because that one is a little tricky. But if you can do that, no stairs will defeat you in Revit ever again. All right. Okay. So that will be it for class today. I will see you guys next week. Same time.
Bye, sir.
Okay. Bye-bye.